Good afternoon, class. We are looking at Statistics Practice Test 1, Module 1, covering chapters 1, 2, 3. Here's chapter 3, describing, exploring, and comparing data. All right. The following data gives the number of hours that a few employees at the GM factory worked last week. And we have a bunch of numbers, 1738 all the way to 25. The very first step is to find the mean. We want to find the mean. So what I like to do is to rank it first, put them in descending order from the smallest to largest, ascending order in essence. So there are 18 pieces of data, okay? And now we are going to calculate X bar. However, it's important to know, I want you to see, we don't need to rank data for some calculations such as finding the mean. However, it's a good practice to do so for those calculations that need rank data. For example, when we look at the median, range, so on and so forth. Because of that, if they are asking you for the mean and the mean only, you don't have to do that. So I like to start with formulas. X bar, because it's a sample, a summation of X over lowercase n. So add them up, 14 plus 16 plus 17, all the way to the last number, 42, divided by however many. There are 18 pieces of data. It's a simple math. You come up with the answer. You always go with a lot of decimals, or you just simplify it in the form of a fraction, or whatever they ask you, because they may ask you to round it, and you round it accordingly. We want to find the mode. And definitely to find the mode, we have to have it in a ranked format. It has to be sorted so we can see that. And there is no mode. Why is that? Because mode is the one that happens with the highest frequency. And since nothing repeats, none of the values repeat, we don't have any mode. Find the median. So median by definition, if you have a rank data, is the middle of the data, and it's right here. Because 18 is an even number, it's between these two numbers, so right here. So what do? Add them up, divide by 2. Add them up, divide by 2. So the median is 25 plus 27 divided by 2, which is 26. Find the mid-range. The mid-range, by definition, is maximum plus minimum divided by 2. So mid-range is the value midway between the max and the mean. By definition, that's the formula. Again, make sure you get to the habit of writing formulas. So max and mean, 42 and 14. This is, for example, a case that if you don't have them in order, you're going to make a mistake if you go with the original one. So you must follow the ranked one, the smallest one, the largest one, add them up, divided by 2. 42 plus 14 divided by 2 is 28. Same thing for the range. We have to have it sorted, ranked. And by definition is the maximum minus the minimum. 42 minus 40. 28. It just so happened those two numbers are the same, which is not the case in general. So note R, the range, and M, R, the mid-range, are not equal in general. In this case, it happened by chance. It just so happened. Otherwise, they are not equal in general. All right, we want to find the variance and the standard deviation. We have calculated the X bar from the previous page. On a normal basis, you use calculators to come up with variance, and the standard deviation is simply the square root of that. But I want to show you, if you were to do it by hand, how it's done. It's extremely important to know the format that we do it. So we are going to write the formula. Because it's a sample, the sample variance S squared is equal to the summation of X minus X bar quantity squared over N minus 1. Or you may use this format, N times summation of X squared minus summation of X quantity squared over N times N minus 1. Any of them is fine. Most of the time, this is easier to calculate. So if we stick with that, N, we already know it's 18 from the previous page. I hope you remember that. Just look at this one. There are 18 pieces. Summation of X squared, that means 14 squared plus 16 squared plus 17 squared all the way to the end. And then minus summation of X, add them up, 14 plus 16 plus all the way to 42, and square that, divided by N, 18 times N minus 1, 18 minus 1. So take a look at the detailed information. We are writing this formula, we are following this formula, and we are plugging in. And I want you to distinguish between summation of X squared, which means individually square them up and add them up. Square this one up, square this one up, and all the way to the end and add them up. Whereas summation of X quantity squared, that means add them up and then square. Now, you put it into a calculator, you come up with the answer. The second method, I want to also show you this one. Again, just for the sake of argument, to see how it's done. And so X minus X bar, so 14 minus 26.9444 quantity squared, plus the next one and the next one and the next one, and the last one minus that quantity squared. So I want to show you. So that comes, that, by the way, you finish it off and it becomes 75. Second format is using this formula. Again, you don't have to do both. You have to write one of those formulas, and then you can use a calculator to come up with the answer. But again, if you were doing by hand, now take a look at the formula. What is the meaning of X minus X bar? That means 14 minus the mean plus squared plus 16 minus the mean squared plus 17 minus the mean squared, all the way to the last number, 42 minus the mean squared over N minus 1. We are looking at this one. So 18 minus 1. And they both give you the same answer, which is about 75. And notice, I put a lot of decimals to make a point. You really have to follow that concept. Now, the next one is to find the standard deviation. And all you have to do, take a root of this S, is the square root of that, which is 8.66. Again, depends on how many decimals they pass through. Find the IQR interquartile range. So let's see what we do. Number one, the IQR describes the middle 50% of values when ordered from lowest to highest. And it's Q sub 3 minus Q sub 1. We already know that Q sub 2, or the median, we added these two, 25 and 27, and divided by 2. Now you want Q sub 1, look at the bottom half, look at the bottom half, and the median, because it's an odd number, 9, so the fifth one, which is number 20, this becomes Q1. And so you're looking at the bottom half. Now you're looking at the top half. For the top half, again, it's odd, so the middle one is the answer, which is the top half is here. Okay. The bottom half, the top half, and the 14th character, which is, or piece of data, which is 34, in this case, number 2. So we write Q sub 2, add these two numbers divided by 2. Here's Q sub 1, here's Q sub 3. And so the inner quartile range is Q sub 3 minus Q sub 1, which makes it 40. All right, what I want to show you is how to use technology. For example, the TI calculator, and you can find this information in the last module of Canvas. So how to enter data to find descriptive statistic. You go with stat, clear list, or highlight, edit, type in, and then you go for summary. So here's how it looks like. You click on stat and clear list. You want to make sure there is nothing in the list. And you choose the list of L sub 1 or sub 2, and you put in the information. And the information that you put in is the way it's given to you. Now, if you go to where it says calculation and one variable stat on a TI, it will looks like this. List is L1, and you don't touch the rest of them. You just click on calculate, and it will calculate the information for you. And you just scroll down. There are a couple of, screens, and notice. This is the X bar that we've calculated by hand. S, or standard deviation, of course, with a lot more decimals here. Q sub 1, Q sub 2, and Q sub 3 are calculated here. Q sub 1, Q sub 2, Q sub 3. We also have the minimum and the maximum value. And this is when we want to do a 5-number summary and whisker plot. I want to continue also showing you the information from Excel. First, you have to input the data into Excel, and then select the data range. Click on sort. There is in the upper right corner, you can go from A to Z or Z to A. So this is what you put in. Then you select them and you sort them, and it gives you the sorted version of the data. Now, we want to get the descriptive stats. Descriptive, we are looking for the mean, median, standard deviation, variance, and there are single commands that will give you that, but you can get all of them in one shot as follows. Make sure data analysis pack is added. You can look up as to how to get that. Click on the data on the Excel, and then data analysis and descriptive statistics. Input the range. The range, you put those cells or those. And check mark label in the first row, the first one is hours, for example, here. Check mark all you need, whatever you need, and then output range looking like this. So for the input, you select this. Label in the first row. If you have selected also the hours, you have to check mark that, otherwise you don't need it. And then for the output, you can go, if you don't do anything, it will take you to a new worksheet. Okay, but if you click a specific range and you click on that, it gives you a chance to go back to the Excel sheet, and all you have to do, enter. But before you do that, you choose what you want. We want summary statistics, summary statistics. So it gives you a lot of information. What are we interested in? Look at the mean. Look at the standard deviation. We have the range, minimum, and maximum. Variance, other stuff, but it's important to know that when you're looking at the variance, this is sample variance, and that's what we want. Now, how do you find Q1, Q2, and Q3? To find Q1, you have to use this command, okay? You put the quartile, and then parentheses. You start from the specific cell to a specific cell and click 1. So quartile, you write down equals quartile parentheses, for example, D65 to D82, comma 1. That gives you Q1. All you have to do, repeat the same thing, changes to 2 and 3, and it gives you the rest of it. So we have Q1, Q2, Q3. Notice Q1, Q2, and Q3 are very close, but they are not identical. And that's why I want you to be careful. Whatever you use is fine with me. And that's why you want to show your work. And with the PDF file, if you show your work properly and your answer is a little bit off and it won't be acceptable there, we can go over it, and I'll be glad to give you the partial credit. Because when the data is large enough, the way various technology calculate this, including Excel and TI, they be the same. But for a small size, and 18 is pretty small size, they may be different. IQ scores have a mean of 100 and a standard deviation of 15. Find the coefficient of variance. So the very first thing, anytime you deal with that, you really have to write the given because you're dealing with word problems. So mu is 100, sigma is 15. Why is it mu and not X bar? Because this refers to all the population. Same thing for this one. So mu is 100, sigma is 15. And what is the coefficient of variance? So let's quickly remind everybody as far as the definition of a coefficient of variance, or short CV. It describes the standard deviation relative to the mean, the ratio of the standard deviation to the mean, and is used to compare standard deviations when the units are different. So simply put, sigma over mu, and you change it to a percentage. So sigma over mu is 15 over 100. We change it to a percentage, becomes 15%. We are done. Use the range rule of thumb to estimate the minimum and maximum usual IQ scores. Well, again, the range rule of thumb says we go 2 standard deviations on each side of the mean, mu plus minus 2 sigma, or X bar plus minus 2s. So mu plus minus 2 times this number, according to the range rule of thumb. This is 30, so 100 minus 30 and 100 plus 30. That gives us the range of 70 to 130. In other words, from 70 to 130, it's the range rule of thumb. We are going 2 standard deviations away, which according to the empirical rule covers about 95% of the data, and most of the time that's good enough. Now, using Chebyshev's theorem, find what is the least percentage of those who will have an IQ score of 70 to 130. Using empirical rule, do the same. In fact, since we've come up with that, we already know the answer is within 2 standard deviations. But let's quickly look at a couple of things. Chebyshev's theorem. According to Chebyshev's theorem, the proportion of values from any data set that fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1. K is not necessarily an integer. K represents the number of standard deviations away. We already know that this meant 2 standard deviations away from 70 to 130. So we know K is 2. But if we didn't know and we wanted to figure it out, I want to quickly show you. Let's say we don't know that. Then you put the mu. Let me just put it here because I can erase it later. We put the mu here, which is 100. And then the number 70 on this side, 130 on this side. So we want to know this distance. Obviously, this distance is the same as this distance, which is 30. But 30 corresponds to how many standard deviations? That's really the key. Just mere 30 doesn't mean anything. So when you divide this by sigma, that gives you 2. This is the value of K, the number of standard deviations. So 30 is how many standard deviations. That's what that K means. So how many standard deviations away from the mean? So K is 2. One other way is you say 100 minus 70 is 60 and divided by 4. Okay. Divided by 15 and you get 4 sigma and then divide 4 by 2. The point is on each side you go 2 standard deviations. So 1 minus 1 over 2 squared. As you know, this is 4, 1/4. 1 minus 1/4 is 3/4 or 75%. So the answer is at least 75% have an IQ score of 70 to 130. Okay. So from 70 to 130, we know that K is 2. Now for the empirical rule, I'm going to remind you about the empirical rule. So we have a normal distribution, a bell curve, where here's the middle of the data or the mean, and on each side we have about that cover that represents the probability, and the whole area under the curve is 1. So we have 0.5 on each side. Now, if we start from the mean and we go 1 standard deviation away, it covers about 68% of the data. If we start from the mean and go 2 standard deviations away on both sides, it covers 95% of the data. And if we go 3 standard deviations away on both sides, it almost covers everything. It covers 99.7% of the data. And because we already know 70 to 130 means 2 standard deviations away, it covers 95% of the data, according to the empirical rule. All right, given the following data, rank the data from smallest to largest and prepare a box and whisker plot. So even if they don't tell us to rank it, in order to come up with the box and whisker plot, we must. So basically put them in order. Three, 4, 5, 7, 9, 14, 15, 15, 16, 16, 19, 19, 32, 50, and we have. To prepare a box and whisker plot, we need 5 items. We need the minimum, we need the maximum, we need the median, we need Q1 and Q3. That's what we need. So first and foremost, let's cut them in 2 pieces. And those are 2 equal pieces. And so the median is somewhere right here, which means 15 plus 15 divided by 2. So that's your median, 15 plus 15 divided by 2, which is 15. Now, to find Q1 and Q3, you have a couple of ways to do that. One easy way, if you look at the bottom, the middle of the data is 7. If you look at the top, the middle of the data is 19, and that works out. But there are other methods that I want to mention that And that is called using the concept of a locator. And n in this case, of course, if you count them, is n, the size is 14 pieces of data. And L is a, so there are different ways to calculate Q sub 1 and Q sub 3. Q2 is just, there's no way around it. This is very simple. But Q sub 1 and Q sub 3, we can go with the locator. N is 14. And locator has the formula L is K over 100 times N. Basically means for Q sub 1, this is 25%. So you multiply the 25% by 14. For Q sub 3 is what? 75%. But the reason we put K over 100, because it doesn't have to be Q sub 1 and Q sub 3, only any percentile. If they said, what is the 7th percentile, then you change the K to 7 and you calculate it. So for Q sub 1, which is 25th percentile, we are going to change the K to 25. And we round this accordingly. It becomes the 4th piece. And 1, 2, 3, 4. 4th piece of data is number 7. We are done. And that gives us the same answer as we did before. Sometimes the answers may be slightly different. For the case of Q sub 3, so 75th percentile, we're going to change the K to 75. And it's 10.5, round up to 11. And the 11th tier, remember this is 7, right? 8, 9, 10, 11. So the 11th piece of data is number 19, as it was discussed before. Now, to come up with the Whisker plot, we need 5 pieces of information. We need the minimum, which is 3. We need the maximum, which is 50. We need Q sub 1, Q sub 2, and Q sub 3. So you draw a number line in essence, and you put those values. So right here is 3, 7, 15, 19, 50. And so what happens is that you draw, for Q sub 1, Q sub 2, and Q sub 3, you draw a box. And for this one, you get just the lines. And it looks like that. And you call this box and whisker plot. Here's the box. And those are the whiskers, the lines that continue. Now what do? We continue with this, and the same question now, we want to see if it contains any outliers. In short, the definition of outlier is something which is way out, it's not of the norm, but more specifically, we are going to define it mathematically, so we know precisely what is an outlier. Sometimes when you look at the data, you can figure out what's an outlier because it's way out. But how would you know precisely? By the way, I wrote the information from the previous page, Q sub 1, Q sub 2, and Q sub 3. And so here's the definition, everybody. The values for Q sub 1 minus 1.5 times IQR and Q sub 3 plus 1.5 times IQR are called the fences that mark off the reasonable values from the outlier values. Outliers lie outside the fences. So the very first thing you have to calculate the IQR, which is Q sub 3 minus Q sub 1. Q sub 3 minus Q sub 1, that gives us 12. Since we are going to multiply by 1.5 and subtract it from Q sub 1, so let's multiply this by 1.5, and that gives us 1.5 times 12, which is 80. Now we're going to follow this formula. Q sub 1 minus 1.5 IQR, which means 7 minus 18, that gives us negative 11. So anything less than this number is an outlier. Or Q sub 3 plus 1.5 times IQR. So that means 19 plus 1.5 IQR is 18. They add up to 37. So any number larger than 37, any number less than -11 are considered outliers. Do we have any outlier? And when we look at the ranked one, we see that on the left side we don't have, but on the right side, the only one is 50 because 50 is larger than 37. Now, for your information, instead of 1.5, if we use 3, it's called an extreme outlier. So you multiply this one by 3, becomes 36. 7 minus 36, 19 plus 36. So 7 minus 36 is minus 29. 19 plus 36 is 55. We don't have to worry about that normally, but in case if they ask, again, outliers within 1.5 of IQR, but extreme outliers, instead of 1.5, we have a factor of 3. Now, continuing with the same question, the question is it symmetric or is it skewed? What is it? So again, we have this, we have the information from the previous page, and we want to discuss that. So I want to remind you what we mean by this concept. So there are a few notes. Number one, make sure the drawing is to scale. If this is not to scale, we really can't tell what's going on. Make sure you have a proper scale. Number two, skewed data show an uneven box plot, in which case the median cuts the box into two unequal pieces. Longer part on the right or above the median indicates data is skewed to the right or positive skew. That means the mean is larger than the median. Longer part on the left or below the median indicates that data is skewed to the left, called negative skew, or the mean is less than the median. Note number three, sometimes the box may look even or uneven and even skewed to one side. However, the whiskers, tails on each side of the box may indicate otherwise. Therefore, pay attention to both. So here's the best course of action. Draw a line, and here's your Q sub 2. Which one is larger? If these two parts are the same, symmetric. If not, skewed. Because this is larger, it is skewed, and it's skewed to the right. So it's skewed to the right, or positive skew, or the mean is larger than the mean. So we justify the answer always. All right, we want to draw the box and whisker plot for this. And let's find, we need 5 pieces of information. The mean and the max are given because it's already ranked, it's sorted. We want to find Q sub 1, Q sub 2, and Q sub 3. So therefore, let's do this. We notice that right in between, we have 8 pieces of data because it's an even number. Right in between these two numbers, that means 86 plus 87 divided by 2 is Q sub 2. So it's very easy to find the Q sub 2. If it's an odd number, just a number in the middle. So you either have even or odd numbers. Again, there are different ways to calculate Q sub 1 and Q sub 3. Here's an easier way. This splits the list into 2 halves, the bottom half and the top half. Since the halves of the data set each contain an even number value, the submedian will be the average of the middle of the two. So in this case, this 2 or this 2, 79 plus 80 divided by 2, 79.5. In this case, 87 plus 94 divided by 2, which is 90.5. So again, look at the bottom half, the middle of the data here. Look at the top half, the middle of the data is here. So Q sub 1, Q sub 3, and Q sub 2 are given. So the 5 number summary, we can write them. The minimum is 77. Q sub 1, Q sub 2, Q sub 3 have been calculated. The maximum is given as 99. And again, I'm going to assume everybody can graph just a number line and plug in those numbers very carefully because we want it to be to scale. And then draw this one again. There's a number line. Very carefully, you pinpoint those numbers and you make up a box here, which contains Q sub 1, Q sub 2, and Q sub 3, and then minimum and maximum. Now, take a look at what happens here. It's interesting. If you look at this is Q sub 2, the left side and the right side are almost identical. They don't have to be identical. They have to be pretty close. So because that's the case, it's not skewed. So what is it? It's symmetric. So data is almost symmetric, normal or bell-shaped. So this is the same as the left side. Now, we are done with this question, but I wanted to add a couple of things in case. So first and foremost, again, the question is completely answered. If we were to find outliers, first we would have Q sub 3 minus Q sub 1. 90.5 minus 79.5 is 11. And Q sub 1 minus 1.5 times IQR, we need to find this. So 1.5 times 11, 16.5. Subtracted from this number, you get 63. Any number less than 63 is considered an outlier on the left side. Now, Q sub 3 plus 1.5 times IQR, which is 16.5, gives us 107. Any number larger than this number is also an outlier. So as it appears, we don't have any outliers. As far as the extreme is concerned, you have to multiply this by 3, becomes 33, and subtract it from Q sub 1 and add it to Q sub 3. So for the extreme outliers, any number larger than 46.5, less than 46.5 or larger than 121.5. I just wanted to add this piece of information. It's got nothing to do with the question. So you can compare and contrast to previous questions that we've done. Also, note if n is odd. Notice if n is what? Even here, because we have 8 pieces of data. Note, we write the same thing. I just make up something and I add 103. Just so I want to remind you the difference, what happens if it's odd. The one in the middle is 87 because there are 9 pieces of data. The 5th one is right in the middle, and that's your Q sub 2. That's very easy to come up with. Now, to come up with, again, easy way out, to come up with the Q sub 1, there are 2 ways they handle it. Either they include 87 with both the bottom half and the top half, or they don't. So if we include that with the bottom half, then the submedian becomes 80, which is Q sub 1. If we include it with the top portion, the submedian is 94, which is Q sub 3. Please understand, some texts may have a different approach, or that locator L formula that I gave you. I hope you can go back and look at L equals K over 100 times N. You can go that route. And that's the reason when we calculate Q sub 1, Q sub 2, and Q sub 3, Q sub 2 is pretty straightforward. Q sub 1 and Q sub 3 may be slightly different depending on the technology we use. And that's why you want to show your work, so I can give you partial credit in case there's a discrepancy. If the mean of a set of data is 23 and 12.6, the number 12.6 has a z-score of negative 1.3, then the standard deviation must be 1. Well, first, get to the habit of writing the given. Okay, so the mean mu is 23, a piece of data x is 12.6, and z is negative 1.3. That's the given. And we are looking for sigma. So we're going to write the formula z equals x minus mu over sigma. And I hope you see if you do the cross product, I'm assuming we are okay with the basic math, you can interchange these two. So sigma becomes x minus mu over z. And all you have to do, see, when you write the given, it makes life easy. Replace the x, replace the mu, replace the z, do the math. And that gives you 8, which is part. So again, the formula will do the job. Find the z-score for each student and indicate which one is higher. So an art major, x is 46, x bar is 50, s is 5. Theater major, x is 70, x bar is 75, s is 7. We are comparing two grades, and since they have different scales, the only way to compare them is to find the z value. And to find the z value, we're going to stick with this formula, or x minus x bar over s, whatever you want it. And you may not know it's a this is for the population, and this is for the sample. You want to stick with either one is fine for this question. So for the art major, I'm going to say AM, x minus x bar, so 46 minus 50 over s, which is 5. You do the math and you end up with negative 0.8. First of all, the meaning of negative, if it's 0, that is precisely equal to the mean. If you calculate this and you get 0, that means the value must have been equal to mean. In other words, if this is equal to 50, you will get 0. When this is less than x bar, you get negative. When this is larger than x bar, you get positive. So a negative z-score doesn't mean the score was negative. It was just below the average, below the average. We do the same thing for the theater measure. X minus x bar over s. So 70 minus 75 over 7. This is also negative. And both of them are negative. That means both are below the average. So which one is higher? Well, both are negative, but this is larger than this one. This is more negative. So the answer is this one. So the theater measure has a higher score than the art measure. Again, both scores below the average score in class. If the 5-number summary for a set of data is 0, 3, 6, 7, and 16, then the mean of the set of data is one of them. And the answer is B. There is insufficient information to calculate the mean. Why is that? The formula. X bar is summation of x over n, or mu is summation of x over capital N. We have to add up all values in the data set and divide by the number of values. We need all data to do so. So if we don't have all pieces of data, we can't calculate the mean. That's the reason behind it. Which of the following is true? And we have D50, P5, Q25, D5, P50, Q2, so on and so forth. And the answer is B, but let's see why the answer is B. So I'm going to give you the following definitions. D stands for deciles, measures of location that divide the data into 10 equal parts. P stands for percentiles, measures of location that divide the data into 100 equal parts. Quartile, measures of location that divide the data into 4 equal parts. So in this case, we have Q1, Q2, Q3. In this case, we have P1, P2, P3, all the way to P99. And over here, we have D1, D2, all the way to D9. So it cuts it into 10 equal parts, 100 equal parts, 4 equal parts. A student received the following grades. Anybody wants to read this for us?
A student received the following grades: an A in statistics, 4 credits, an F in physics 2, 5 credits, a B in sociology, 3 credits, a B in literature and a literature seminar, 2 credits, and a D in tennis, 1 credit. Assuming A equals 4 grade points, B equals 3 grade points, C equals 2 grade points, D equals 1 grade point, and F equals 0 grade points, the student's grade point average is.
Perfect. We use what's called weighted average or weighted mean. And this is how your GPA is calculated. When different X data values are assigned different weights, W, we can compute a weighted mean. To find the weighted mean of a variable, multiply each value by its corresponding weight and divide the sum of the products by the sum of the weights. So let's do that. And by the way, I hope you realize why, because just for the sake of argument, if you have 1A and 1B, A is 4.0, B is 3.0, it doesn't mean that you're going to get necessarily 3.5, because if A is worth 5 units and B is only 2 units, then you have a larger value than 3.5 as your GPA. So I hope you see why the weighted average. So we have the grades of A, 4 units or 4 credits. We have F, 5 units. We have B, 3 units. Then we have another B, 2 units, and D, 1. So let's put that in front of them. So I hope everybody can see how we arrive at this. And how much is worth? A is worth 4, F is worth 0, B is worth 3, and D is worth 1. So this is the general formula explaining that you're going to multiply these 2 columns and add them up. So 4 times 4, 5 times 0, 3 times 3, 2 times 3, 1 times 1. This is how your GPA is calculated, the weighted average. And then however many units, you add up all these units and that becomes your denominator. So again, multiply this column by this column, 4 times 4, 5 times 0, 3 times 3, 2 times 3, 1 times 1, and add up these numbers, put them at the bottom, you get 32/15. And normally we go with 2 decimals, however many decimals they ask you, 2.133 is the GPA for that semester for that student. Given the data set we have here 10, 44, 15, 23, 14, 18, 72, 56, find the value that corresponds to the 75th percentile. And now we go with this concept of a locator. The very first thing, we must sort the data, rank the data from smallest to largest. So let's do that. It's very easy to do. So we put this in order: 10, 14, 15, 18, 23, 44, 56, 72. So I hope you remember that we said L is K over 100 times N. And in this case, what is N? 1, 2, 3, 4, 5, 6, 7, 8. Because we want 75, we're going to put the K as 75. So 75 over 100 times N, or 0.75 times 8, it's 6. And the way statisticians do, most of them, because it's a whole number, they go between 6th and 7th. 1, 2, 3, 4, 5. This is the 6th one. This is the 7th one. And they add them up. 44 and 56, they divided by 2. 100 divided by 2 is 50. 30th percentile, we do exactly the same thing here. And instead of 75, we're going to use 30. So K is 30. 2.4. And again, the way that the statisticians do, they round this up. If it's 2.1 or 2.5 or 2.9 makes no difference. They go to the third one. So the third value, where is the third value? 1, 2, 3. So the answer is 50. They go to the third one. Find the percentile corresponding to number 44. Now the other way around. What is the percentile that corresponds to a specific number? The formula is that you have to find the number of values less than that number and divide by n. So percentile, number of values less than whatever that number, since we want 44, less than 44 divided by n. Obviously, n, we know it to be 8. How many are less than 44? 1, 2, 3, 4, 5. There are 5 numbers less than 44. So 5 over 8. And all you have to do, change this to a percentage in essence, change it to a decimal, becomes 0.625 or 62.5%. And you rounded accordingly. I want to make sure we understand what happened here. This means (62.5%). And when you rounded accordingly, P63. If you put P62.5 is okay, but we rounded accordingly. Using range rule of thumb, estimate the standard deviation. So how do we use the range rule of thumb to estimate the standard deviation? I hope you remember that mu plus minus 2 sigma or x bar plus minus 2s, 2 standard deviation on each side, which is a total of 4 standard deviation. If you go from the left to right, that was the range rule of thumb. So to roughly estimate the standard, so recall, this is what I was mentioning, the range rule of thumb. Estimating value of a standard deviation. To roughly estimate the standard deviation from a collection of known sample data, we use S is almost equal to range divided by 4. So what was range? Max minus mean, and then divided by 4. So range divided by 4, max minus mean, 72 minus 10, which is 62, divided by 4, 15.5, according to the range rule of thumb, is the estimate of the standard deviation. Would somebody read this question, please? The following data representing numbers of keyboards assembled for a sample of 25 days in a company. So 42, 52, 48, so on and so forth. Construct a frequency distribution table with 4 classes. Normally, when you're on your own, you decide on the number of classes, and it has to be a limited number, okay? But for the sake of a homework, normally they give us the number of classes. So the very first thing is always rank data, sorted from smallest to largest. I'm assuming nobody has any problem with that, as it appears the smallest number is 41, the largest number is 56. Now, the method by which we find the FDT, the frequency distribution table, is to estimate the width based on the number of classes. And that would be to divide the range, which is 56 minus 41, by the number of classes. So the width is range divided by the number of classes. Range is 56 minus 41. divided by 4, and we end up with 3.75. Now, remember, you're making up a frequency distribution table. So this, you can use this number, but it's really not a nice and round number. It becomes hard to work with, but you must round up. Even if it's 3.1, you go to 4, you round up, because if you round down, you're going to miss some of these values when you make up your table. You can even try it. Round up. So obviously, we're going to round it to 4. So the width happened to be equal to the number of classes. It's just by accident, okay? It's just by chance. So the width is 4. Now the question is, where do we begin? We always begin either with a number, with the smallest number as the lower limit of the first class, or something slightly smaller than that. Lower limit of the first class, starting point is a convenient number less than or equal to the smallest value, such as 41. You can even try with 40, but what is absolutely important is that by the time you finish, you must include 56. If you start with 40 and then with the width of 4, we never get to 56, then that's not a good choice. That's why I highly recommend you start with 41. So if you start with 41, what happens? 41 to some number, then we have to figure out the rest of it. Since the width is 4, remember how we calculate the width? Just add the width vertically in the first limit. So this becomes 41 plus 4, 45. So add this to this, and this becomes 45. This becomes 49. This becomes 53. Now this one, you add, remember if you recall the width, let me just write it here. The width for limits was upper limit minus lower limit plus 1 unit. So if you go with this formula, you have the lower limit for the first class, which is 41. And if you plug in with the width of 4, this becomes 44. You can try. So with this formula, we have the width of a 4. Upper limit is missing. Lower limit is 41. So you take it 41, minus 41 and 40 becomes minus 40. You take it to the other side, becomes 44. And there you have it. So 41, 45, 49, 53, we have already had it. If this is 44, all you have to do, add the width of 4, 48, 52, 56. As far as the frequency, so we want to go from 41 to 44. Okay, so again, we're going to look at this one. We're going to write 41, 42, 43, 44, 44 as the first one. So just look at the very first one, never mind the rest. If you look at those, you say you have 1, 2, 3, 4, 5. So this number is 5. The next one starts from 45 and ends with 48. So it starts from here and ends here. So we put them here. Now count 1, 2, 3, 4, 5, 6, 7, 8. So you put number 8 here. The next one is 49 to 52. So start from here, go to here, write them here. 1, 2, 3, 4, 5, 6, 7, 8. This is also 8. And then 53 to 56, from here to here, there are only 4 pieces. And you write the frequency. So this is FDT. FDT, frequency distribution table. Now we're going to use the same topic and we're going to add the following. Use the data to find the mean. Use the frequency distribution to find the mean. So since we have every piece of data, we can find the mean. X bar is summation of x over n. 45 plus 52, the very first number was 45, and then it was 52, and then it was 48, and all the way to the last one, which was 42, or use the ordered one. It doesn't matter. Divide by however many. There were 25 days, 25 pieces of data, and we get 48.48. So it's very easy to calculate. Add up all the values, divide by the size, you have the answer, you're done. Now, in this case, you are assuming you don't have this, you are estimating the mean. But the purpose of that is to show you whether they are close or not. So to estimate the mean, what do we have to do? We're going to use this formula. X bar is summation of f times x sub m over n. Everybody knows f is the frequency, n, of course, is the size. If you add them up, obviously you get the 25. But what is x sub m? And I want to explain this one. FDT, frequency distribution table, does not give us every piece of data. Again, never mind that we started with that, we ended up here. Assuming you're given that and not that. We don't have every piece of data, therefore we can't use this methodology to find the mean. So we use x sub m, which is the midpoint of each class. So we guesstimate or estimate that each piece of data in each class is equivalent to its midpoint. That would be a good estimate. So what is the midpoint here? 41 plus 44 divided by 2. Remember the lower limit, 41, plus the upper limit, 44, divided by 2. And that gives us 42.5 because the width was 4. Just keep on adding 4. 46.5, 50.5, 54.5. So lower limit plus upper limit divided by 2. When we add this to divide by 2, we get this one. We can do the same thing here. We just add the width of 4. And so this times this, this times this, this times this, this times that's the top. Add them up, divide by 25. So 5 times 42.5, 8 times 46.5, 8 times 50.5, 4 times 54.5, and add them up, divide by 25. And notice, are the two means reasonably close? Take a look at the values. In the first case, we have the exact answer because we have used the summation of data divided by the size, summation of x divided by n, which is a precise mean. This one we estimated it using frequency distribution table, and that is why this midpoint works pretty good. And the answer is yes, they are reasonably close. It's a nice estimate.